All right, I'm gonna do 4 different videos that talk about normal distributions and using the inverse normal distribution to do inverse z-score work. I'll do an example where we're finding, you're given the left tail. I'll do an example where you're given the right tail, and we'll do a middle probability, and then we'll do a percentile and a z-score from the middle percent. And after these sort of 5 shorter videos, you should be able to do all of the homework problems, even if they're sort of presented in a different way. So I'm going to live in the husky examples. The weights of adult male huskies are normally distributed with a mean of 55, which means that's the number in the middle, and a standard deviation of 6. Find the weight of the lightest 30%. So we want to know how much would a dog weigh down here if we know 30% of the data is below it. Okay, that will represent the lightest 30%. If we can get this dog weight, we can then know all dogs under that represent the smallest 30% of dogs. So I need to get the z-score that is associated with a 30% left tail. So I'm going to take 30% as a decimal, 0.3, and that's what I'm gonna go bring over to my spreadsheet, okay? So I just have a nice empty spreadsheet. I'm going to type in, just to sort of make sure it's nice and clear for the rest of the time, this is where I'm gonna put the left tail probability that we want, and this is gonna be the z-score that's associated with it, z-score. So we said we wanted a left tail of 0.30. So we want to know what z-score has 30% of the data below it, has a left tail of 0.3. We're going to type in equals norm.s.inv, which you see will naturally pop up. And then in those parentheses, you can either touch the 0.3, so then it's kind of programmed, or you can just type it in directly, 0.3. That's what I'll do this time. And boom, we get a z-score of negative 5244. Negative 0.5244. So a z-score that is negative 0.5244 standard deviations below the mean will represent 30% of the data as a left tail. So now we can plug this into our formula where we can find the specific data point, the specific weight of a dog that will represent the lightest 30% of huskies. And we do that by taking the mean plus the z-score that's connected to the left tail probability we want times the standard deviation. So this will be 55 is the mean of the population we're dealing with, plus the z-score we just found, times the standard deviation given in the problem. We'll go type that into Desmos, plus negative 0.5244 times 6. And we will get that a husky that weighs 51.9 pounds or less will represent the lightest 30% of the huskies.